Hi, my name's Jordan. Today I'm going to walk you through a workflow that I've been using as part of my daily software engineering work over the last few weeks. The workflow is really simple. Basically, I start by asking OpenAI Deep Research to produce a software spec that's readable by an LLM. I feed in it all the details of what it is I want to produce, and it produces a detailed specification for me. I then take that specification and feed it into O1 Pro and ask O1 Pro to generate the basics of the code for me. I then take the output of O1 Pro and put them into Visual Studio Code, and then ask GitHub Copilot Agents to go and pull apart the code and create all the files and everything that I need for the project. I pay for my own subscription to OpenAI Pro, and I know it's very expensive. I think it's around 200 USD, but in Australia it puts it over $300. And it's cheap by no means, and certainly in this day and age where we're used to sort of $10, $20 a month online subscriptions, it's a lot of money. But what I'm finding more and more is as I get my head around how to effectively use it as part of my daily workflows, I'm finding it a super important tool, and I think the value for money is becoming greater each day that I go back and use it more, not just for generating software code, but also for other areas of my work. So today, as I said, I'm going to run you through a very simple workflow to hopefully demonstrate the value in some of these tools.
Okay, so what I'm going to do here is basically, I'm just making a bit of a prompt here for deep research. What I want to do is essentially this file here, which there's a lot of these. I just found the one for my region by going through the BOM website, which is the Bureau of Meteorology in Australia. Basically, it contains a whole heap of information on rivers, and their current status. So basically, the whole this contains every river in Queensland. We've got a cyclone incoming, so I'm very interested in the river data at the moment. What I'd like to be able to do is essentially write a little program that can extract a particular river out and then tell me its height beta. So and also its status. So if it's increasing or going down or whatever else like that. So what I've thought is I've actually downloaded the file, and here's the sample of it here. What I might do is I might just grab a little bit of some sample code here. Okay, so what we've got here is today we're going to download a file. So what I've got is generate a software specification from LLM that can read and generate the code from the following requirements. I'm going to feed this into deep research. It's going to go and search and pull together code samples and do all sorts of things to write a spec. And after that, I'm going to feed it into O1 Pro to actually generate code or at least a representation of it. And I'm going to feed that into here and use GitHub Copilot Agents to actually generate the working software project. So for now, though, we need to work on this spec. So today we're going to download a file and parse out the data for a particular river. Okay, first of all, I'm going to add some things here. You must assume the LLM knows very little about how to write actual code. So research and provide snippets where appropriate. I think you must use, we want to use beautiful soup to parse. Okay, and that's just some tree rules, things like that. So let's go. Today we're going to download a file and parse out the data for a particular river. The file is in an anon FTP server. Here is the sample URL, but this should be we'll just do configurable by .env. Okay, so we know how to do that. Okay. Files are in. And there's the sample URL. Okay. And then let's sample content from that URL. Content is in HTML. The content is in HTML. Parse it and load every river into a data set. Then give me a method to filter it. Make sure you, what else do we need? Let's have a look here. So this is It should be in Python. Okay, let's what I might do is I might just drop this in because and then it should show the output with nice colors in the terminal. It should write the output. Let's actually change it by command line arts. So we get the input file. All right, so the content should be, the content is in HTML, the input content. Parse it and load every river into a data set and give it a method to filter it. Should show the output with nice colors in the terminal. For the command layers, the river to filter to should also be available from command line args. Cool. All right, that'll do. Let's copy that across into deep research and see how we go. All right, let's make sure we click deep research here, and let's pop in our prompt. What it usually does is ask me a few refining questions. So let's see what it says here. Okay, preferred output file. Let's do prefer. Right, so what's done is I put it in, and then before it does all this extra, a lot of work to go and parse, go and actually generate this, which can take quite a few minutes, up to 10 minutes and things like that. Basically, what we want to do is it wants to clarify some things before it goes off and does like that. So it's sort of picked up some things that might be important to this. So yes, prefer markdown, prefer snippets, please. No pref on if it lives. Okay, should the output be in JSON? The output file, JSON, please. Yes, it should handle errors. Hey, that'll do. All right, there we go. Let's generate that. All right, now we just have to wait. Okay, we have our specification. What I'm going to do is I'm not going to read it here. What I'm going to do is just copy it, and then we'll go back into our code here. Let's add a new file. This one here is deepresearch.output. Output.prompt. Okay, output. It's not a prompt. It's a okay. All right, so let's drop preview this rule. Let's see what we've got. Okay. All right, so we don't need this. There we go. Okay, this specification tries Python script. Looks pretty good. There, the FTP server. So there's some arguments. So it's sort of given us some pretty good how to do the arg parsing. Okay, how to download a HTML file from a thing. Connection retrieval. It's using FTP lib. Okay. Okay, this snippet FTP. Okay, interesting. It's using retrieve binary or something like that. It's not scrolling very well on that side. I think HTML content was beautiful soup. All right, so it's going to actually save the file and parse it. Okay, fair enough. Extracting the data. Okay, so it's finding the tables. We'll see if that actually works. Because the table might not have been the first table, might not be the last table. So we'll see if it sort of iterates all tables. Or it does seem to, maybe not. We'll see how we go. Structuring as a list of dictionaries. Cool. So that's what we do want. We want it to come out as a data set sort of thing. And then Then we're doing colorite. So we're doing colorama to output some nice stuff. Cool. So we should get some nice river data out. Okay. And it writes it out to a JSON file. Should dump the data, the filtered data out to the JSON file. Cool. All right. This looks pretty interesting. So the error handling strategy down here. It's got all sorts of things there to error handle conclusion. All right, let's copy this. Let's copy our thing here. Let's go to a new folder and call it .github. And in there, we're going to create another new folder called prompts. And in here, we're going to go call one codegen.prompt.md. Now, you will generate this code. Use multiple files. Ensure a README is generated. We don't have to ensure, just generate a README. Generate a README.md, generate a make file, generate requirements, txt. Did I spell it? Yes, I did. Requirements.txt. What else do we need? That'll do for now. We don't need to go overboard. Try to keep the code simple and split up code files into modules where it makes sense to avoid large code files. Okay, we won't do unit tests yet. We'll do them later because we don't want to overcomplicate this first prompt. Okay, we're in Code Insiders. Let's try and generate this. Hey, all right. Where are we? All right, so let's go in here. Ask Copilot. We're going Copilot Agents. So we're going to make sure we're on Agent. We're on 3.7. I'm going to add a file. This time I'm going to add a prompt. And I'm going to see how it's got the code gen prompt there. Generate this code. Okay, the rest of it sort of comes from the prompt. So let's see how we go. We're just going to hit run. It'll take a second to parse it all. I might just get rid of this this here so we've got a bit more room to look at. There's a lot of information for it to parse, but already it's reading the whole project there. You can see that's the project on an individual file. So we've got the requirements, beautiful soup and colorama. Beautiful. So we started off good. Okay, we're getting the main project file now. Looks like we're going to get some modules in. Cool. Got to create that folder. So see, it just asked me to run a command. It's created the modules folder now. Cool. It's using iParse to parse the arguments. Let's do it properly. I wish these were the same argument. It should split it up and just let you put in one FTP file. That's that full path. FTP downloader using FTP here. Cool. We've got a parser. Opens the file, loads it into beautiful soup. Cool. Or even is using headers and everything. Cool. Data processor. This does some filtering by the looks of things. It's going to filter that out and return us the result. What else did we just get? Output handler. So this is going to do some nice, pretty output by the looks of things here. Nice. Got an init for the module. So the module behaves as a module. We'll probably get a make file next. README. Awesome. Cool. All right. Cool. So even added a license and everything. Got a make file coming in now. Ooh, it's pretty detailed. So we can install the pip requirements. giving me a bit of a summary now on what it's done. Okay, so, I mean, all that looks really good. I'm going to keep all of that. What we're going to do, though, is in the makefile, it's not using a real, I don't know what that's doing. It's not using a real, I'm going to get it to add using this real URL. So we've got the prompt here. Let's go add a makefile example to use. What was it? Oh, here it is here. Okay, we'll just add the makefile here, update the makefile. So use a river exam using that URL. So it'll probably split it up, add the entry to the makefile. This is pretty cool. So when it edits this file, it's going to actually show what it did, like a git diff, so that I can accept it. You'll see it editing it. It'll run down and edit it in each line at a time, so you can sort of see what the model's doing, which is pretty sweet, I reckon. Okay, here goes the editing. No changes. Yep. There's the example there, so you can see that's what's added. So let's just wait for it to finish here. So split it up good. Run make example. So what it's going to do is it's actually going to run it, and then so it'll ask me to run it. So it's not going to do it by itself. I'm going to click OK, and it's going to do it. And then what it's going to do is if there's any errors or anything like that, it's going to read the output and actually fix it. So okay, so it's looking. Unfortunately, it's looking for Brisbane. Okay, so let's just. Okay, so now so it didn't actually find the river Brisbane because it's just not in there. Because it's not actually one. So I need to actually get the real name of the river, which I'll do in a second. But it's actually looking at the HTML file. Okay, yeah. So it's failed because it's looked at the HTML file and it's found that it never had a river named Brisbane. So I'm just going to stop that because what did it download? Is that the file that I wrote? I think it is. So that's fine. What I actually want is one called Kumara River at actually I've just looked for the weir at Oxford Weir. This is the one we want here. Search for this river. Use this river in the example. Make sure that okay, so we're going to use that one next. We know it's present, and that's the river I'm interested in actually. So but also see it's got a bit of junk on the end. We just want to make sure that it sort of ties it up and supports that. Whether it does trimming or whether it does substringing or something like that, just to check, if it contains the river name contains that or whatever. Let's just see what's going on there. Exact and partial name. Ooh. Whoops. Okay, that's annoying. Past the rate limit. Can I keep all of that? Okay, I'm going to switch to 3.5. And then what I'm going to do is I'm going to go run it. Should have done all the heavy lifting in 3.7 now. 3.5 is more than capable to finish the job. Let's go and make example. Okay, look at that. Whoa, it worked. Wait a minute. It's printing out all the rivers. Interesting. Okay. It should only give out the river. Okay, so it seems to have the partial matchings. Let's just have a look at the makefile here and see what it actually searched for an example, because it should only. See here. Please use this name in the example search. So we're still searching for Brisbane. Let's fix that. So that's certainly working. So it's printing out nice colors. You can see the height is also in nice colors there. Tendency, the trend is steady. Okay, so we don't need the recent data there either because that's just, we can remove that field. So we'll do that next. So let's go there. Cool. And then it should automatically, because I said to run it before, I think it'll know that still, and it will actually say, it will actually automatically run it. Continue, let's download that file. Okay, ooh, that one river, nice. All right, so it was just saying, it was interesting before it said I can't see colors, but you can see colors. So if you're happy with it, then, go for it. Okay, let's remove, we don't need the recent data field. E.g. recent data table. Okay. Editing the HTML parser. Looks like we are so yeah, I see. It's actually just removing it if it's not recent data. Okay, cool. All right, so it's gone. Recent data is gone. Love it. Thank you very much. We'll keep all of those edits, and then we're happy. We can check. We can check that in. I reckon, just about done. Okay, finished. Editing finished. Now, all of that's a really interesting example that works. You can see how I generated it, but what I actually did is took that same concept to the next level and actually had it generate a Home Assistant plugin. Now, Home Assistant is a quite a vibrant open source project with a very active user community, and there's all sorts of plugins for it. Now, you can get plugins that talk to your air conditioner or your car or anything else, but there was no plugin to talk to river height data. So what I actually did was create a spec in the same method that I demonstrated. I also generated some code, all in the same method, in not only reading the river height data, but actually going through and creating a Home Assistant river height sensor, which basically then what it does is it exports the data that I've collected using my little script there and brings it into Home Assistant. So I can see the river near me is 1.5 meters. It's got a bit of history there. It seems to be going up and down a little bit. You can see when it was last updated. You can see with the river status, which is below minor flood level. And the trend is that it is actually rising at the moment. So you can see it's falling, rising, steady. We'll just keep an eye on that. As that river trend changes, I'm actually, Home Assistant do all sorts of stuff. One of them is send messages to your phone. So as it changes, I'm going to get a little message on my watch and on my phone that says, hey, the river's changing. You might want to keep an eye on that. And I can just see that in here. So that's pretty cool. But the code that it generated, it actually wrote, it even made it so that it can be automatically installed into Home Assistant using its thing. So it structured the repo in a way that is supported by this plugin, the plugin system in Home Assistant. It shows you how to configure it. It helped me write all of this as well. So that's a bit of YAML that Home Assistant needs. It split out the configuration variables in the help file here in the README. Showed another more advanced example, and also showed a way to automate it. So when the river's high, you can see that it actually notifies the mobile app, and it generated all of this. I just sort of sat there with it like it was like a really competent, awesome software engineer, and I was like the engineering manager that was helping it along and giving it hot tips and using my experience to guide it towards successful outcomes. But essentially, it wrote most of the code. I just did a few little fix ups here and there. Of course, it generated the river height information here. There's a manifest here that will actually, it generated this that shows how to, this is for Home Assistant to know what it's looking at. And then, of course, the sensor code here, which basically you can see, I won't go through it because it's quite long. It probably should be split up a bit, but essentially, if you have a look down the bottom, it shows a little simple example on how it runs. Same URL, same station filter. Basically, it generated a little mock to ensure that it can work outside of Home Assistant because Home Assistant injects some stuff. And basically, the river height data is then fetched by this sensor and then it's exposed. In this way, we're just pulling the data out and printing it. But if it was in Home Assistant, it would be able to read it and actually expose it to its systems. And so that's how that was all made. The URL for this is up here. So that's the repo there. Public, you're able to look at that and install it in your own Home Assistant. Should you have it and living in Australia.